Hi everyone, so welcome to our lecture on chi-square test of independence. So chi-square test of independence is probably the most frequently used hypothesis test in social sciences. So test of independence here, chi-square test of independence is actually one of hypothesis testing between two qualitative variable. Okay, I repeat, qualitative variables. So in this exercise, we will use the chi-square test of independence to evaluate group differences when the test variable is nominal or ordinal or group interval. Just to recap back what is group interval. Group interval means group data. Okay, like for example, when you have a question or a variable on age. So on age, when a respondent responds to the question of age, they will put a figure. For example, 20, 23, 40, 41, 35, and so on. So you have a lot of data, different data, and maybe there are few data which is in the same age, they will have a same data. So group interval here means you group your data. For example, like 20 and below, 21 to 30, 31 to 40, that will be in group interval. So SPSS will treat group interval as categorical. Categorical here means qualitative, all right? So it's the same with nominal or ordinal or group interval. So the chi-square test of independence can be used for any variables, any groups, and test of variables is to look at independence or dependent, and sometimes it can be independent and independent. So chi-square test of independence is to look or is to investigate the relationship between two variables. Are there any relationship or no relationship between the variables? So the variables here we are talking about is qualitative variable and qualitative variable. I give you an example, like for example, gender and the response of yes and no. Is gender is influencing the response of yes and no. Okay, so we can investigate, is there any relationship between gender and the response of yes and no, or are there no relationship between gender and the response to yes and no. So independence defines, so two variables are independent if for all cases the classification of a case into a particular category of one variable, so the group variable such as gender has no effect on the probability that the case will fall into any particular category of the second variable. Meaning to say, the selection of the second variable is not affected by the first variable. Okay, so when the first or the second one is not affected by the first or the second one, so the two variables are independent. So the same example that I use, if the response of yes and no is affected by the gender, so they are relationship. But if the response of yes and no is not affected by the gender, so this is example of independent two variables. So when two variables are independent, there is no relationship between them. So we would expect that the frequency breakdown of the test variable to be similar for all the groups. So example here, suppose we are interested in the relationship between gender and attending college. So if there is no relationship between gender and attending college, and 40% of all the samples attend college, we would expect 40% of males in our sample to attend college and 40% of female to attend college. Meaning to say, the example here, we are looking at gender and attending college. Is are those who attending college has a difference between gender. Okay, I mean here is gender affecting the entry to attend the college. So let's say the total sample of the youth to attend college is 40%. So we would expect 40% of male and 40% of female in the population attend the college. So here, example here means the proportion is equal between the gender. So if the proportion is equal between the gender, so there will be no relationship. So gender is not affecting variables of gender is not affected. Oh, sorry, is not affecting the entry to attend the college. But if there is a relationship between gender and attending college, we would expect a higher proportion on one group to attend uh, to attend college than the other group. For example, 60% is male, 20% is female. This is just an example. So the proportion is different. So maybe gender influence or affecting the result of those who attend college. So if you look at the first graph, okay, if you look at the first graph here, so total 40%. So if you have equal between males and female, so this is what we are expecting of independent relationship. Mean to say gender has no relationship with college attending. Okay. But another example here, total 40, but male is higher compared to female. Okay, so this is the example of maybe they are relationship. Okay, gender has a relationship. This is maybe we have not done our test of independence yet, so we will check on this later on. Okay, has a relationship. Okay, if we have done our test of independence. So independence demonstrated. So suppose we are interested in the relationship between gender and preference of major of study. So if you look here, this is variable 1. Okay, variable 1 here is gender, is between male or female. Qualitative. Okay, so it's a qualitative. So preference of major of study. Okay, bidang pembelajaran. Okay, preference of major of study. Variable 2, qualitative also. Okay, both must be qualitative. And I repeat again, test of independence is to investigate the relationship. Are there any relationship or there are no relationship between the two variables? So example here, a group of 300 were randomly selected and asked whether he or she preferred taking liberal art courses in the area of math science, social science, and humanities, or humanities, sorry. So if you look gender, our first variable just now, the data is either male or female. So we have two types of data here. Favorite subject area or the major study area, major of study, we have the second variable, we have 1, 2, 3. Okay, we have 1, 2, 3. So we have three types of data for favorite subject area. So a group of 300 were interviewed. So the total here will be 300. So if you look, total of male will be 1 to 2. Total of female will be 178. Okay, total of math science 72, total of social science 113, and humanities 115. So, so this bar graph is a descriptive statistic. Okay, descriptive statistics. So looking at the bar graph, it appears that there are differences. Okay, there are differences. So if you look at math science, male is higher. If you look at social science, female is higher. If you look at humanities, female is higher. So differences in the proportion of females and males preference for each subject. So does this sample present sufficient evidence to reject our null hypothesis? So here, null hypothesis here will be, this is different if we compare to ANOVA hypothesis testing for one population, hypothesis testing for two population. The hypothesis testing in our previous lecture that you have learned is on quantitative variables. And when we compare between groups, the groups will be a qualitative variables. But for chi-square test of independence, null hypothesis will the key word will be there are no relationship, or the two variables are independent, or it can be not related. Alternative would be there are relationship between the two variables, or the two variables are dependent or related. So does this sample present sufficient evidence to reject the null hypothesis? Meaning that when we reject null hypothesis, they are relationship because looking at the difference here, okay, there are difference in proportion. So test of independence will try to investigate, are there any relationship between the two qualitative variables. So how does this test of independence work? So test of independence here, there are one calculation that you need to do, which we call it as expected frequency. What we are observing here, okay, like for example now 37, okay, 37 is the frequency of male who choose math science. 41 is the frequency of males choosing social science, and humanities 44 is male choosing humanities. So all the figure here is what we call as observed value or observed frequency. Okay, observed frequency. So in this test of independence, we need to calculate our expected frequency. So what is expected frequency? So expected frequency is the frequency that we accept the null hypothesis. Okay, so what does null hypothesis say? There are no relationship, or the two variables are independent, or the two variables are not related. Okay, no relationship or independent or not related, meaning to say the proportion should be equal. For example, like male male female. Okay, the proportion should be equal like this. So to calculate this, that's why we need to calculate our expected frequency. So to look at the proportion, So the formula will be total of row, total of, sorry, total of row times total of column, okay, total of column divide by total respondent, okay, total respondent. So in this case, for example, here, okay, what is the expected frequency of 37? 37 is the observed value. Okay, 37 is the observed value. So now we want to calculate our expected value for 37. So this is our expected value, or expected frequency lah. I just put EF, okay, expected frequency. So how does we calculate this? Will be, I put it here, 72 times 122, okay, total of row times total of column. Total of column is 72 and total of row is 122, divide by overall total 300. So it will be 72 times 122 divided by 300. So 29.28. So meaning to say the expected value for 37 will be 29.28. Okay, now we do 35. So here will be total column 72 times total row 178. Okay, 178 divide by 300. 72 times 178 divide by 300. 42.72. Okay, so now we do for 41. So total column 113 times total row 122 divide by 300. 113 times 122 divide by 300. 45.95. Okay, now we do for all. Okay, 72. So for 72 will be 113 total column times total row 178 divide by 300. You will get 67.05. Then for 44, so total column 115 times total row 122 divided by 300. So it will give 46.77. And for 71 will be total column 115 times total row 178 divided by 300. You will get 68.23. Okay, now just to double check, okay, just to double check. So we total up all the expected value. Okay, kita jumlahkan semua expected value, we total up. So the first one is 29.28 plus 42.72 plus 45.95 plus 67.05 plus 46.77 plus 68.23. So the total will be 300. Okay, same with the overall total. So if you get 300, meaning to say all your calculation is correct. Okay, all the calculation is correct. So this is expected value. So if the observed value is like the expected value, similar or almost similar, usually there will be the two variables between gender and favorite subject area will be independent. But if the differences is very large, so it will be dependent. So we need to do a calculation. Okay, we need to do calculation. So expected frequency are computed as there is no differences between the two groups. Okay, like what I mentioned just now, expected frequency we calculate to assume we accept the null hypothesis. Means that there is no differences between the groups. So both groups have the same proportion as the total sample in each category of the test variable. So two random variables x and y are called independent if the probability distribution of one variable is not affected by the presence of another. As defined in the conditional probability, independence requires of probability math science given that maths, okay, given that m equals to probability of math science, sorry, mel. So probability of math sign given that male is equals to probability of math sign given that female, okay, is equal to probability of math sign. So male and female here is not affected. Okay, the proportion is the same or the probability is the similar. Okay, it's the same. So that is gender has no effect on the probability of the present person choice of subject area. So meaning gender is not influencing the choice of a subject area. So if both events are independent, then probability of A and B is equals to probability of A times probability of B. Since the proportion of subjects in each category of the group variables can differ, we take group category into account in computing expected frequency as well. So to summarize, the expected frequency for each cell are computed to be proportional to both the breakdown for the test variable and the breakdown of the group variable. So expected frequency versus observed frequency. So the chi-square test of independence plug the observed frequency and expected frequency into a formula which computes how the pattern of observed frequency differ from the pattern of expected frequency. So the formula here will be observed frequency minus expected frequency divided by expected frequency and we total up. So this is chi-square independent test of independence formula. Okay, later on we will try to calculate the same example that we have gone through our expected frequency just now. So the chi-square test of independence is a test of the influence or impact that subjects value on one variable has on the same subject values for the second variable. Okay, to look at the relationship. So to test the relationship, we can use the chi-square test statistic, which follows the chi-square distribution. So chi-square distribution here, we have another set of table. Okay, so we will refer to chi-square distribution table. Okay, later on I will show you. So step of hypothesis. So Sam, we have 5 steps. Okay, we have 5 steps. Step number 1 is to state the hypothesis. Okay, So we have null and we have alternative hypothesis. So subject area preference is independent, not related or no relationship of the gender of the college student. Alternative will be there is not independence or dependent. Meaning to say subject area preference is dependent of the gender of the college student. Okay. Step number 2, calculate our chi-square test statistic. Okay. So this is the formula. Sorry, I forgot to write square. Okay, we need to have square because we want to remove the negative value. Okay, we will remove the negative value. So we need to calculate our test chi-square test statistic value. Okay, step number 2. So in the formula we have expected value here. Okay, expected value. That's why you need to calculate your expected value that we have calculated here. Okay, so these are all expected value. Okay, expected value. So O is the observed frequency and E is the expected frequency. So E here is the expected count if X and Y here means subject area preference and gender are independent, meaning to say we are favor to null hypothesis. That's why we calculate our expected value. So we are looking of difference between observed frequency and the expected frequency. Okay, kita lihat perbezaannya. So since the null hypothesis says these factor are independent, we would expect the values to be distributed in proportion to the marginal totals. So the expected value is calculated on the assumption that null hypothesis is true. So null hypothesis here means gender and subject choice is independent or no relationship or not related. So there are the calculation that I have shown you just now. So there are 122 males and we would expect them to be distributed among math science, social science and humanities proportionately to the 72, 113 and 115 totals. Thus, the expected cell counts for males are, this is how we calculate just now. Total of row times total of column divide by overall respondents, okay, the sample size. So we would expect for female. So after calculate, so this is what we have calculated just now. Okay, ini yang kita dah kira tadi. So the total here will be 300 if you calculate, if you total up all the expected frequency. Okay, after you calculate the expected frequency. So test of the second step to calculate the chi-square test of independence. So this is the formula. Okay, this is the formula. Sum of, this is sum, sum of in bracket observed frequency minus expected frequency in bracket square divide by expected frequency. So you need to do one by one. So if you have 1, 2, 3, 4, 5, 6 here, you will have 6. 1, 2, 3, 4, 5, 6. Okay. So you must have 6 calculation made. So the first one, 37 minus 29.28 in bracket square divide by 29.28. So 37 minus 29.28 will be 7.72 square will be 59.59 divided by 29.28. So you will get 2.035. So same goes to the second, third, fourth, fifth, and the sixth one. So after that, because we have sum here, you need to total up. So 2.035 times a plus 0.533 plus 0.164 plus 1.395 plus 0.365 plus 0.112, you will get 4.604. So 4.604 is our chi-square value, okay? Chi-square test statistic value. So this is step number 2, okay? Step number 2. So step number 3 is to determine or to identify the significant level. Significant level. So let's say this example, the significant level is our alpha is 0.05, okay, 0.05. Then because here we are using chi-square distribution, okay, chi-square distribution. So referring to the table, we will have degree of freedom, okay, we need to calculate our degree of freedom. So if I show you the table, okay, so this is the table, chi-square distribution table. So here we have degree of freedom. First column, degree of freedom. So how does we calculate our degree of freedom? Okay, so degree of freedom, the formula will be total of column minus total of minus 1, sorry, I repeat, degree of freedom equals to total of column minus 1 times total of row minus 1. This is how we calculate our degree of freedom. The first row here, this is our chi-square, okay, or our probability for chi-square, or we can just put probability, okay, because we can use to calculate our p-value if we want, all right. So this is the probability area under the curve. So if you look here, the curve here is not symmetrical. Remember, the two variables are qualitative. Okay, so we cannot assume normality in this test. Okay, there are no such thing as normality because the variables that we use here is qualitative variables. So we look at the example just now. Okay, example here. So if we check our example here, total row degree of freedom. I put here step number 3. Step number 3. Degree of freedom equals to column minus 1 times row minus 1 equals to, so column, how many column we have? 1, 2, 3. So 3 column, 3 minus 1 times row. How many row? 1, 2. So 2 row, 2 minus 1. So equals to 2 times 1. So the answer is 2. Okay. So this is step number 3. Okay. So the degree of freedom, like T distribution, the chi-square distribution has degree of freedom. So the formula is row minus 1 times row column minus 1. Okay, column minus 1 times row minus 1, degree of freedom, where C is the number of columns and R is the number of row shows in the two-way table. So if the display contingency table has 3 column and 2 row, like the example just now, so the degree of freedom will be 2. Okay, 2. So this is the chi-square distribution table that I have shown you just now. So we will get back to the exercise later on. So step number 4, we have done our step number 2, number 1, number 2, and number 3. So step number 4 is to look for our critical value. How to look? So alpha significant level is 5%. So alpha here is 0.05. Okay, 0.05. So degree of freedom 2, degree of freedom 2, kita lihat 2 row 2, row 2, degree of freedom 0.05 just now here. Okay, so this is your critical value. Okay, this is the critical value 5.991. So critical value we have identified 5.991. Okay, so step number 5 is to compare step 2 and step 4. Okay, step 2 and step 4. So the table for the assumption of the table is not normal. So here critical value is 5.991. Okay, so this area is the rejection region, our alpha. Okay, rejection region, and this part is non-rejection region. Okay, non-rejection region. So compute, after compute, second step, our chi-square statistic value is somewhere here, 4.604. So 4.604 falls under non-rejection region. Okay, so compute. Step number 2, 4.604. Step number 4, critical value 5.991. So computed chi-square test statistic is smaller than the critical value. Okay, smaller, meaning to say critical value is larger. So as it lies inside the non-rejection region, so we fail to reject the null hypothesis. We conclude that the preference of the academic subject area does not depend, okay, or no relationship, no related, or independent on the gender ataupun sex of the respondents at the 5% significant level. So alternatively, we say sex of students has no significant influence on the preference of the subject areas. So this is how you make your conclusion. But let's say example in step number 2. Okay, if step number 2 computed will be, let's say 8.0. Okay, here example only. If our step number 2 after calculation is 8, so if you look, critical value 5.991 and 8 is somewhere here, step number 2. Okay, so the value of 8 is in the rejection region, our alpha. So our conclusion will be we reject the null hypothesis, and when we conclude that the preference of the academic subject area is significantly related to the sex of respondent at the 5% significant level. Okay, so this is how you make your conclusion in step number 5. So let's get back to this example, just to give you an idea on how should we look for p-value or critical value. Okay, so the question here is about p-value. So a chi-square statistic was computed for a two-way table having degree of freedom of 4. So the value of statistic was 9.49. So what is the p-value? Okay, so we can check 9.49, degree of freedom 4. So we look at row 4 here. 4 only. Kita tengok yang 4. 9.49 here. So the answer will be 0.05. Okay? 0.05. The answer will be C. Okay, 0.05. Okay, let's look at the second one. A chi-square statistic was computed for a two-way table having 20 degree of freedom. So the value of statistic was 29.69. What is the p-value? Okay, so we check degree of freedom 20 and the test statistic value was 29.69. Okay, we go to 20. 29.69 is somewhere here. We don't have the correct one, so it's somewhere middle here. Okay, middle here. So it will between 0.5 to 0.1. Okay, it will between 0.5 to 0.1. So we check where is the closest answer. So it will between 0.5 to 0.1. Okay, so the answer here will be C. Okay, C will be the answer because it's in the middle. Another example here. Okay, another exercise. So the value of chi-square test statistic is 5.33. Are the results significantly significant at the 5% significant level if the degree of freedom is 2? Okay, so like we have calculated our degree of freedom equals to 2, alpha equals to 0.05. So our critical value that we have calculated just now is 5.991. Okay, 5.991. Okay, so uh, so our test statistics step number 2 is 5.33. Okay, so A, if you look here, critical value 5.99, our chi-square test statistic is 5.33. So 5.33 is still less than critical value. So our decision will be do not reject. H null. So do not reject H null here means we are favor that the variable 1 is no relationship with variable 2. Okay, no relationship. So are the results statistically significant? So statistically significant is referring to alternative hypothesis. So the answer will be, because here do not reject means meaning to say we are favor to null hypothesis. So when we are favor to null hypothesis, the answer will be no, because we are not referring to or we are not favor to alternative hypothesis. So the result is not statistically significant. So yes, answer will be wrong. A and B is wrong. So we look at C and D. So C and D, the difference is between the critical value. Okay, so the critical value is 5.991. So the answer will be C, no, because 5.33 is smaller than the critical value of 5.99. So the answer will be C. Okay. So decision making using p-value approach. So it's the same like the previous lecture. So if your p-value is greater than significant level, your decision will be do not reject null hypothesis. But if your p-value is less than your significant level, your alpha, so meaning say alpha is greater than your p-value, your decision will be reject null hypothesis. So by rejecting null hypothesis, your conclusion will be there are relationship between the two variables. If you do not reject null hypothesis, your decision will be there is no relationship between the two variables. So p-value approach, the null hypothesis of the independence assumption is to be rejected if the p-value of the chi-square test statistic is less than the given alpha. Okay, p-value smaller than alpha, reject null hypothesis. Okay, reject null hypothesis. So uh, your your conclusion will be we conclude that there is a relationship because you are favor to alternative. But if your p-value is greater than alpha, so your conclusion will be there are no relationship. Okay, there is no relationship between the variables, the two variables. So if the probability of the test statistic is greater than probability of alpha, so we fail to reject the null hypothesis, and we conclude that there is no relationship between the variables, or we can say that the variables are independent. So given chi-square test statistic 4.604, the corresponding of the p-value of degree of freedom is about 10%. Okay, 10% here means 4.604 degree of freedom 2. Okay, so degree of freedom 2, 4.604 is somewhere here, which is very close to 0.1. So let's assume 0.99, or just we put 0.099, or we can assume it is 0.1. So here the example is almost 0.1. So we assume the p-value is 0.1. So p-value 0.1 is greater than alpha 0.05. That's why the decision is not to reject null hypothesis. Okay, so do not reject null hypothesis. We cannot reject the null hypothesis. So another example here. In the general social survey, respondents were asked what they thought are most important to get ahead: hard work, lucky breaks, or both. What is the null hypothesis for this situation? Remember, null hypothesis. Null hypothesis. So null hypothesis usually says about no relationship, not related, or independent. So we read at A, there is a relationship. Wrong. A is wrong. There is no relationship. Okay, this is correct. So we will look at the answer later on. C, there is a relationship. So this is wrong. C is wrong. There is no relationship. Okay, true. So we look at B and D. Okay. So B, there is no relationship between gender and opinion on what is important to get ahead in a sample. Remember, null hypothesis and alternative hypothesis is a statement to make or conclude decision for population. Okay, this is the concept of hypothesis testing. Why we do hypothesis testing? And remember, hypothesis testing is under inferential statistic. Inferential statistic is about generalize or we make conclusion about a population. So if you talk about sample, so this is wrong. Look here, there is no relationship, answer for D, there is no relationship between gender and opinion on what is important to get ahead in the population. So the answer is D, because it is referring to population. Okay, it is referring to population. Okay, the other question here, what is the alternative hypothesis? Alternative hypothesis will be, okay, let's say this D is no relationship. Alternative will be, you just delete this. So if you delete this, there is relationship. So this will be the alternative. There is relationship between gender and opinion on what is important to get ahead in the population. Null hypothesis, there are words of no relationship. Okay, there is a word of no relationship. For alternative, the word will be there is a relationship. Okay, so that is the difference between null and alternative. Okay, example here. What is the value of the test statistic? Okay, test statistic will be 5.476. Okay, chi-square test statistic value is 5.476. What are the degree of freedom for this testing? Okay, so we need to calculate. So row we have 1, 2, 3. Column we have 1, 2. So degree of freedom equals to C minus 1 times row minus 1. So total column is 3 minus 1 times total column is, total row, not to make confused. Column we have 2, male and female, minus 1 times row we have 3 minus 1. So 1 times 2. So the answer will be 2. So at the significant level of 0.05, what conclusion can you make between gender and the opinion to get ahead? Okay, so here we can refer to our critical value, but here also we are given p-value. So if your alpha is equals to 0.05, if we use the p-value approach, we compare between the p-value 0.065. So p-value now is greater than alpha. Okay, greater than alpha. So meaning to say, do not reject null hypothesis. Okay, do not reject null hypothesis. This is using p-value approach. But if you want to use critical value approach, so we can refer degree of freedom to alpha is 0.05. We have referred just now. Degree of freedom to alpha 0.05 is 5.991. Okay, critical value is 5.991. So we need to say, if I draw here, so this is the alpha rejection region. So 5.991. So if you look at chi-square value 5.476, so it's somewhere here 5.476. So 5.476 is in the non-rejection region. So the conclusion will be, do not reject null hypothesis. They are, the two variables has no significant relationship between them. Okay, meaning to say, gender and opinion to get ahead have no relationship. Okay, tak berkaitan. Okay, here a researcher is interested to know which or with whom it is easier to make friends. So 205 first-year students from the FSS were randomly selected to participate in the interview. So expected value. So first we have observed value, then you need to calculate your expected value. Okay, expected value. Then you calculate. So here do we have the answer? No. Okay, so you need to calculate your expected value. So after calculating your expected value, you need to do your second step. Okay, calculate your chi-square test statistic value. So later on, you may try. Okay, you may try. This is how you need to calculate the expected value. Like for the first one, uh, here, 48.79. How to get it is 73 times 137 divided by 205. So you will get 48.79. Same goes to here. Uh, for example, here 135, sorry, 137 times 29 divided by 205, you will get 19.35. Here 103 times 68 divided by 205. 103 times 68 divided by 205. You will get, sorry, this is wrong, 34.17. Okay, yeah, this is correct. 34.17. Okay, 34.17. I repeat, 103 times 68 divided by 205, you will get 34.17, not 36. Okay, not 36. So you do for all here. After that, you calculate, okay, sum of observed value minus expected value in bracket square divided by expected value. So this is the formula for chi-square test statistic, step number 2. So do we have evidence to support that it is easier for men and women to make friends with the same sex or opposite sex at 5% significant level? So step number 1, there is no relationship between sex of students and the perception to make friends in the population. And your alternative hypothesis will be there is a relationship. Okay, beza dia no and is. Okay, tidak ada hubungan, null hypothesis. Alternatif ada hubungan. Then step number 2. Okay, after you calculate the example here, the test statistic value is 8.515. Okay, 8.515. So assumptions critical level, significant level is 5%. Okay, assume the significant level is 5% and the degree of freedom 1, 2, 3, 3 column here and 1, 2, 2 row. Okay, so 3 minus 1 is 2, 2 minus 1 is 1. So 2 times 1 is 2. So degree of freedom is 2. Okay, 2. So the critical value is 5.991. So now we check. This is critical, sorry, this is test statistic value. And our critical value is 5.991. So if you look, chi-square test statistic value is larger if we compare to critical value. So if larger, So the decision will be reject null hypothesis. Okay, so we reject the null hypothesis and conclude that there is a relationship between the respondent's sex and respond to the question asked in the population. Okay. So here in this example, I have two questions. So I want every one of you to try first. Okay, to try, and I will give you the answer later on. Okay, I will give you the answer later on, but please try it first. Okay, please try. So this is the first question, and this is the second question. Okay, must try. So suppose a random sample of 650 of 1 million residents of a city is taken. So in which every resident of each of the four neighborhood. So A, B, C, D, we have four neighborhood here, is equally to be chosen. So the null hypothesis says the randomly chosen person neighborhood of the resident is independent of the person's occupational classification, either blue collar, white collar, or service. So test of hypothesis is alpha equals to 5%. So use the 5 step. Step number 1, state the null hypothesis and the alternative. Step number 2, calculate the chi-square test statistic value. So before you calculate, you need to calculate your expected frequency. Okay, you need to calculate your expected frequency. After that, you insert all or you do your calculation for your chi-square test statistic value. Step number 2. Then step number 3 is to identify the alpha. So here is 0.05. Then you need to calculate your degree of freedom. Okay, row minus 1 times column minus 1. So we have 1, 2, 3. 3 row here, blue collar, white, and service. 3 row here, and column we have A, B, C, D, 4 columns. So column minus 1, 4 minus 1 times 3 minus 1. So 4 minus 1 is 3. So 3 minus 1 is 2. So 3 times 2 is 6. So degree of freedom 6. Then fourth step is to identify the critical value. So using the degree of freedom equals to 6, and area to the right, we look at the rejection region, alpha equals to 0.05. So what is your critical value? Then you compare step number 2 and step number 4. So if your step number 2 chi-square test statistic value is greater than your critical value, your decision will be reject null hypothesis. But if your chi-square test statistic value in step number 2 is lower or smaller than your critical value, so your decision will be do not reject null hypothesis. And you conclude that there is no relationship between the two variables. So please try to do the two questions here. Okay, the two questions. I will ask someone to post the answer in the WhatsApp group later on. So exercise here. Okay. So which of the following relationship could be analyzed using chi-square test statistic? Okay. So relationship, like what I say, the two variables must be qualitative. Okay, must be qualitative. So we look at A, height. Height is not qualitative, it's quantitative. Weight is not qualitative. Okay, so A is wrong. A is wrong. B, the relationship between satisfaction with K-12 school, satisfied or not satisfied, this is qualitative, and political party affiliation. Okay, so both are qualitative. So the answer is B. Okay, the answer is B. Okay, we look at A again. A, height. Okay, height. Height is quantitative and weight is quantitative. So what kind of test here? So the test here will be correlation. So correlations will be your last topic after this topic. Okay, after this lecture will be your lecture on correlation. So B is the chi-square test. Okay, C, the relationship between gender. Gender is qualitative and amount willing to spend in dollar, quantitative. So this is a hypothesis for two population. Okay, C is hypothesis for two population. Okay, for two population. Or if you use SPSS, is using independent sample t-test. Okay, I will show you in the tutorial, SPSS tutorial session. Okay, D, the relationship between opinion, qualitative, and income earned in thousand. Okay, so if you have two opinions, it's using hypothesis of two population. If your opinion is more than two, three or more, you will use ANOVA. Okay, it can be ANOVA or hypothesis for two population. Okay, so if you look here, opinion or gender is qualitative. So we are comparing groups. Okay, but A and B, we are looking correlation and chi-square. This is chi-square. These two, okay, these two, we are looking at relationship. So we are trying to examine the relationship between the two variables, either qualitative and qualitative or quantitative and quantitative. So more exercise. So a student survey was done to study the relationship between where students live. Okay. Dormitory, apartment, house, co-op, and parents' house. So we have 5 data here on this one variable and how they usually get to campus. Walking, bus, bicycle, car, subway. We have another 5 for another variable. So what are the degree of freedom? C minus 1 times rho minus 1. So see here 5 minus 1 times 5 minus 1. So 4 times 4 will be 16. The answer is 16. Number 2. The chi-square test involves a set of counts called expected counts, or what we call as expected frequency. Yeah? What are expected counts or expected frequency? Remember, before we look at the answer, expected counts is favor to null hypothesis, meaning to say, it is proportion to look at what should be the frequency if we do not reject null hypothesis or we favor to the null hypothesis. So hypothetically count that would occur if the alternative hypothesis were true, wrong. Hypothetical count that would occur if null hypothesis were true. The answer would be B. Okay, we look at C. The actual count that did occur on the observed data, wrong. The long run count, wrong. Okay, so the answer is B. So because we are favor to null hypothesis, kita berpihak kepada null hypothesis. So a researcher conducted a study on college students to see if there was a link between gender and how often they have cheated on exam. So she asked 2 questions on a survey. What is your gender, male or female? 2 types of data, okay, male or female. How many times you have cheated? One, never, one or two times, the second data, 3 or more times. So we have 3 data. What is the appropriate null hypothesis? So we can just put there is no relationship, because we are looking at null, that's why we have no relationship between gender and number of cheating in exam. Okay, so B, what is the degree? Sorry, before we go to B, so if B, A kan, what, another question, what is the appropriate alternative hypothesis? If the question is asking for alternative hypothesis, so use the same one like this, but you start with there is a relationship between gender and number of cheating in exam. Okay. Okay, B. What is the degree of freedom? Formula, column minus 1 times row minus 1. So column, let's assume column is the gender. 2 minus 1 times row, we have the number of times of cheating. So 3 minus 1. So 1 times 2. The answer will be 2. Okay, so it's a bit simple. So this is the command of using SPSS to calculate the chi-square test statistic. Okay, this is the command, but I will show you again in the SPSS tutorial. So this is an example of output, okay, of output. Like the previous lecture, if you use SPSS, you just need to understand the concept of p-value. P-value greater than alpha, your decision will be do not reject null hypothesis. If your p-value is less than alpha, then you reject your null hypothesis. So here, if you look, the first table here is descriptive statistic. This is the observed value, the word of count, observed value. And here is the expected count or expected value. The the word that we use just now, okay, the alphabet, that the symbol that we use. C is the, sorry, not C, O, in the formula. O, observed value, is the count. E is the expected frequency or expected count. Count here means, or the observed frequency is the frequency that we have collected through the survey. Okay, and E here is the expected. We look at the proportion if we favor to the null hypothesis. So SPSS will calculate everything for you. Okay, SPSS akan kira untuk semua. So the second table here is the inferential statistic table. So what you need to check is Pearson chi-square. Okay, Pearson chi-square, assumption significant. So this is the p-value. So now let's say our alpha is 0.05, p-value is 0.000. So alpha is greater than the p-value. So your decision will be reject null hypothesis because p-value is smaller than alpha. Okay, so there are relationship between qualification join when they join UNIMAS and the faculties. Okay, so qualification here play different, or the students from STPM matriculation and diploma is affecting the choice of faculty. Another example here. Let's say now alpha also 0.05. So this is the p-value. So the p-value here is 0.115. So p-value is greater than alpha. Alpha is 0.05. So the decision will be do not reject null hypothesis. Okay, do not reject null hypothesis. So you conclude that there is no relationship between study throughout the semester rather than just cramming before examination and satisfy with the current CGPA. Okay, there is no relationship. So this is how you make your decision. So if you use SPSS, you need to use p-value approach. I repeat, if your p-value is larger or greater than your alpha significant level, so your decision will be do not reject null hypothesis and conclude that there is no relationship between the two variables. But if your p-value is smaller than the compared to the alpha, so your decision will be reject null hypothesis and conclude that there are relationship between the two variables. Okay, ada hubungan kalau kamu reject null hypothesis. So this is the end of the lecture. So I hope you will try to do the two questions. Okay, the two questions that I ask you to do. I will ask someone to post the answer in the WhatsApp group. Then we will discuss in the WhatsApp group. So all the best and stay safe and thank you.